video, I want to talk about one of the example of SAT math problem. And the question is the line y is equal to kx plus 4, where k is a constant is graphed in the xy plane. If the line contains the point c, d, where c is not equal to 0, as well as d is not equal to 0, and what is the slope of the line in terms of c and d? So if you write our function down, y is equal to kx plus 4. And they mention about in terms of c and d, which means we cannot find the exact value of our slope of the function. So if we analyze this equation right over here, and before we do that, let's think about our solutions for this question. At first, we need to think about our linear functions properly. And also, we need to think about in terms of finding the slope of a linear function. And it will going to become an approximate value. So if you look at our function right over here, we can feel that this is a linear equation, which means the first degree x power. And we know that if we analyze this function, we know that 4 is a y-intercept. Y-intercept means in the coordinate plane, the x-coordinate is 0 and the y-coordinate exists, which means it is a y value when the x value is equal to 0. And if you look at our k right over here, we usually make it an expression as m, but they wrote it as k. And for k, it is a slope of this function, the slope. Slope means it shows how steep the function is. And also if you look at our y, it is a output of the function. So for this term right over here, k value and the 4 is unvariable, which means the value of it never change. So it will depend on the output will gonna depend on the x value. So if you look at it, the thing that we want to find is the value k. And they mention about the point c, d. So the point c, d. And the thing that we know that these points are not equal to 0. So using this property, the thing that we want to find is a slope of the function. But for the slope of this function, the way to find it is a formula that we did in the last video, that it is, if there is a point something, I'll call it x1 comma y1. If there's another point x2 comma y2, the way to find it is by subtracting y2 from y1 and then over x2 subtract from x1. And this is a way how to find our slope of the function. The reason why I'm subtracting those points is to see how the change of the function, and that shows how steep is a function is, which means it will show us a slope of the function. So we don't know the value of the c, d, so we can just write it down. And then we know one more point, that 4 is a y-intercept, which means the x value is 0 and the y value is 4. So we can write it down again, so 0, 4. And this is the main case that we can find a slope in terms of c and d. So at first, if we think about this, I'm gonna call this term right over here c, d as x2 and then y2. I'll just call it like this. And I will call 0, 4 as x1 and y1. So if we use our property of our slope formula, it will going to be d, so y2 minus y1, d minus 4, and then over 0, so c minus 0, which will going to be just c. So at first, if you just write our 0 down, it will going to be c minus 0, but 0 is just 0, so we're going to cancel it out. And if you simplify this, we get minus 0 is just 0. We get c in the denominator, and in the numerator, d minus 4. And this is our approximate slope in terms of c and d. So we can see that our answer for this question will going to be d minus 4 over c, which is a in this case. So for our graph of this function, we cannot find it, we cannot graph it. The reason is because we need to have a full linear function. So we need to have full linear function, which will going to be y is equal to mx plus b. But we know a value of the b, which is 4 in this case, but we don't know a value of the m. The reason is because in order to find m, we need at least 2 points, but we don't know a value of the c and a d. So that means we cannot find an exact value and we cannot graph it. And in this video, what we did is, at first we analyzed the function, which was our linear function form. And in order to find the slope using our pattern, we use y2 subtract from y1 over x2 minus x1. The reason why we are doing this is because we want to see change of x coordinate as well as y coordinate, because that shows how steep is a function is. The steep is function is will show our slope of our function.